Here we have a SAT math problem. Okay, let's go to the question. In the figure above, AB equals to 12, AC equals to 15, and CD equals to 6. Both line segments AB and CD are perpendicular to the line segment AC. If the area of triangle AB is P and the area of triangle CDE is Q, then what is the value of P negative Q? Okay, here the area of triangle ABE over here is given, that is P, and the area of triangle CDE over here, that is Q. Okay, once we get the areas of these two triangles, and we have to do subtraction between P and Q, that is we have to get the value of P negative Q. Okay, if I want to get the area of this triangle ABE, I need the base and height of the triangle, because we know the formula to get area of a triangle is 1/2 times base times height. Okay, for this triangle ABE, we can consider this side AB as base, because we know the length for AB. So we can consider this AB as the base. The base of the triangle is 12. Okay, so how do we have to get the height of the triangle? First, let me draw the height of the triangle ABE. Let me draw a perpendicular line from the vertex E to the side AB of the triangle. So here it intersects at right angle. So let me say this is point F. So this line segment EF represents the height of the triangle ABE. Okay, now let's consider the triangle CDE. So for this one, we have the area Q. Okay, now to get the area of this triangle, the same thing, we need the base and height. We can consider the CD as the base, because we have the length for the CD. So the base of the triangle is known, that is 6. So still we need the height of this triangle to get the area. Okay, now let me draw height, that is, let me draw a perpendicular line from the vertex E to the side CD of the triangle. Since it's a perpendicular line, it intersects the side CD at right angle. And let me mark this point as G. Okay, now our aim is to get the heights of the two triangles, that is EF and EG. How do we have to get the heights of these two triangles? For that, we can consider this particular piece of information, that is the line segments AB and CD are perpendicular to the line segment AC. Since both these line segments AB and CD are perpendicular to the same line segment AC, we can consider this line segment AB over here and the line segment CD over here are parallel. Okay, when we consider AB and CD are parallel, then this AD becomes transversal and this BC also becomes transversal. Okay, when we consider this AD as transversal, then the angle measure over here, angle measure over here are equal, because they are alternate interior angles. And also the same thing, angle measure over here and angle measure over here are equal. The same thing, that they are alternate interior angles. And also the angle measure over here and angle measure over here are equal, because they are vertically opposite angles. So that is the three angles of triangle ABE are congruent to the three angles of the another triangle CDE. So in two triangles, if all the three angles are congruent, then the two triangles are said to be similar. Okay, now let me write the similarity statement. First, let me take the vertex A in this triangle ABE. The corresponding vertex is D in the second triangle over here. Let me write it. And now let me take the vertex B in the triangle ABE. Okay, let me write it. And the corresponding vertex is C. And the third vertex over here is E. And for this one also, we have the same E as the third vertex. So these two triangles are similar. Okay, if I take the side AB in the first triangle, what is the corresponding side in the second triangle? That is DC, or it can also be written as CD. Okay, already we have the lengths for the both AB and CD. That is, let's find the ratio between the corresponding sides AB and CD. That is equal to 12 to 6. Okay, here there is a common divisor for the two terms of this ratio, that is 6. Let's divide both the terms by 6. When I do so, when I divide 12 by 6, I'm getting 2. Here 6 by 6, I'm getting 1. Okay, now I got the ratio of the corresponding sides, that is 2 to 1. Since these two triangles are similar and the corresponding sides are in the ratio 2 to 1, the heights of the two triangles also must be in the same ratio 2 to 1. So that is the height of the triangle ABE is EF. Let me write over here. And the height of the triangle CDE is EG. Let me write over here. So the two heights must be in the same ratio 2 to 1. Okay, from this ratio, if I want to get the heights of the two triangles EF and EG, I have to multiply the terms of the ratio by the same non-zero number, say x. That is, when I multiply the first term of the ratio 2 by x, I'm getting 2x. This 2x represents the height of the first triangle, I mean ABE. And when I multiply the second term of the ratio with the same non-zero number x, that is 1 times x is x, this x represents the height of the second triangle CDE. So that is the length of EG over here. Okay, so here the length of EF is 2x over here, and the length of EG over here is x. And also we know that AFGC over here is a rectangle. In a rectangle, opposite sides are parallel and also equal. So since the length of this AC is 15, the length of this FG also must be 15. That is, when I add 2x and x, that is the length of EF and AG, it must be equal to 15. So clearly 2x positive x equals to 15. Then 3x equals to 15. When I divide both sides of this equation by 3, I am getting x equals to 5. Okay, here when I plug in x equals to 5 in this one, 2 times 5 will become 10. So 10 is the height of the triangle ABE. So when I plug in x equals to 5 over here, 5 is the height of this triangle CDE. Okay, now for both the triangles of the base and height. Okay, now let me get the area of the triangle ABE, that is called P, because the P represents the area of triangle ABE. So area of triangle ABE equals to, the formula to get area of the triangle is 1/2 times base times height. Okay, here 1/2 times. For this triangle ABE, the base is 12 and the height is 10. So we can plug in 12 for B and 10 for H. 2 goes into 2 1 times and 2 goes into 12 6 times. So here 1 times 6 is 6, 6 times 10 is 60. That is 60 square units. So that is, I got the value of this lowercase v, that is 60. Okay, now let's get the value of Q, which is the area of triangle CDE. Let me write the stuff over here. Area of triangle CDE. Again, we can use the same formula, that is 1/2 times base times height. Okay, here 1/2 times the base of this triangle is the CD, that is 6, and the height of the triangle is 5. Okay, let me plug in 5 for H. 2 goes into 2 1 times and 2 goes into 6 3 times. So okay, here 1 times is 3, 3 times 5 is 15. Okay, here I got the value of Q, that is 15. Already we got the value of P, that is 60. Our aim is to get the value of P negative Q. Okay, now let's get the value of P negative Q. P negative Q equals to, for P we know that 60, negative for Q we have 15. So 60 negative 15 is equal to 45. Therefore the value of P negative Q is 45.